All right, so 4-3, this is triangle congruence by ASA and AAS. Take a look at those. ASA, AAS. What do you notice? Two angles, one side, but two different theorems, okay? And that's where this one gets a little confusing, is which one are you actually using? So I'm going to try and make that crystal clear to you how these work. If I lose you, just ask. Tell me to slow down. So angle side angle is ASA. And what this one says is if two angles and the included side, okay, what is the included side going to be? If you have two angles, what is the included side of those two angles? Remember last week we said, here's a triangle, and you have two sides. The included angle was the angle between the two sides, right? Now we're saying you have a triangle, here's two angles. What's the included side going to be? The side between the two angles. So your included side would be this one on that triangle, okay? So it says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent, okay? So if you have an angle, side, angle with an angle, side, angle, where the side is between your two angles, those triangles must be congruent, okay? We would say triangle ABC is congruent to triangle DEF by angle, side, angle. Two angles and the included side. So take a look at this first example here. This says which triangles are congruent by ASA. Take a look at those three pictures. Which two are set up as ASA? If we call this triangle 1, triangle 2, triangle 3, which two? 1 and 2. Why not 3? This is not included. This would be the included side, right? This is not an ASA setup, okay? So we know it's not this one. But then once we know which triangles are that ASA setup, it's still important that you give a congruent statement that is true. So if we're looking at these two triangles, we would say triangle. So if I say UVS, what triangle is UVS congruent to? It's an O, but yes, EON. So I went from one arc to two arcs to no arc, UVS. That means on my other one, I have to go from one arc to two, so EO to none, N. Okay, so we would say triangle UVS is congruent to triangle EON by angle, side, angle, and that would be your congruent statement. Questions on that? All right, let's try a proof. Let's just stop and think through the important things in a proof. When you look at a proof, what things should you be thinking, I need to make sure I do this, or I see this, or what? Tell me what is important about a proof. The given, okay? So you always want to name the given information. You want to look at the given information because the given information is there for a reason. Why would they tell me that this angle is congruent to that angle, or that this side is congruent to that side, or something is a midpoint, or something is a bisector, okay? So the given information is important. What else is important in a proof? Bless you. how about what they're asking you to prove, right? You got to know your end result. Where am I trying to get in this process? Well, in this one, we're trying to prove two triangles are congruent. And that always goes where? The very last step. So triangle ABC is congruent to triangle AED. So that's our last step every time, is what did they ask me to prove? How do I know it? All right, so step one, look at what they gave us. All of that information would go here because it is given. But then look at what information they gave you. It says CAB is congruent to DAE, and they marked that. It says BA is congruent to EA, and they marked it. And then they say angle B and angle E are right angles. Did they tell you that those two angles are congruent? They didn't tell us they're congruent. They told us they're right angles. What does that mean? That means they're both 90. That means they are congruent, right? But you have to say that. Angle B is congruent to angle E because all right angles, do you remember doing that last chapter? All right angles are congruent. Okay, so then knowing these are congruent, can you tell me those two triangles are congruent?
Yes.
By what?
ASA.
ASA, angle, side, angle. Any questions on that? Okay. Then the next one. And this is where I feel like it gets a little bit tricky for some, just because of what things look like. Okay, the difference in our pictures. So this one is angle, angle, side. So angle, angle, side. Notice your S is no longer between your A's. Okay, you no longer have the included side, which means there's a little more room for error, because if you think about a triangle with two angles, you could have this side as the non-included side, but you could also have that side as the non-included side. So you could have AAS on one triangle and AAS on a different triangle, and they're different AASs, right? So that's where you got to be careful with this one. Here's what it says. If two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. Okay, so look at the picture. Angle A is congruent to angle D. Angle B is congruent to angle E. And then BC is congruent to BF. So we can say triangle ABC is congruent to triangle DEF by angle, angle, side. So now here's what I want you to see. If I take those same two triangles, but I ditch this side and I make it this side instead. Now do I know by AAS that those two triangles are congruent? Because I went angle, angle, side, and I have angle, angle, side. So they both have an AAS setup. Am I matching up the corresponding parts? No. Okay, so you got to be really careful with this. This is not AAS. Even though it's two AAS setups, they have to be the corresponding sides that are congruent. So I could have said this side with that side, and then it's AAS, or I could say the top one with the top one, and then it's AAS. But if one is the top one and one is the bottom one, and they're next to a different angle, right? This goes double arc, single arc side. This goes single arc, double arc side. That's not the same thing, okay? You have to go in the same order. Match up the corresponding pieces, okay? Okay, so take a look at this proof. One other thing about this, technically, if it's AAS, which is why we come up with AAS, how do I know this angle is congruent to this angle? Third angles theorem. So technically, AAS can also, if you prove it this way, be ASA, right? Which is how they come up with the fact that there even is an AAS. Just a little fun fact for you. Okay, example 3. Let's do a proof. Things to look at. They gave you information that is important. Do you remember what I said often shows up if they're telling you lines are parallel? Why would they tell you lines are parallel? To prove sides or angles? Angles, to prove alternate interior angles typically, right? So look for that. So they told us M was congruent to K, and they told us these two lines are parallel. That's all your given information. So all of this goes here. Your last step is going to be what they're asking you to prove. Triangle WMR congruent to triangle RKW. That's the end goal. That's where we want to get in this setup, okay? All right. So what I need you to figure out is what we are missing. What do we need? Currently, you have an angle congruent to an angle. We don't have any sides congruent. We don't have any other angles congruent. We need 3 things: SSS, SAS, ASA, or AAS. Those are the options. When you're proving triangles congruent, it is going to be one of these. Your job is to figure out which one. So knowing what we know, is there anything else you can tell me is congruent in this picture? Any angles that are congruent or any sides that are congruent? Okay, so we know WR is congruent to WR. How do we know that? It's reflexive. It's the same line. So you can say reflexive. Side note, if you put that as your step 3 and you put something else as your step 2, that's okay, because these 2 steps don't impact each other. What else do we know? What's the thing in our given that we've not addressed yet? Parallel lines, right? They told us parallel lines for some reason. Your job is to figure out what reason. Now, here's where you have to be a little bit careful, because one set of angles is congruent by AIA and the other one is not. These are the parallel lines. So which angles are congruent? If this is our transversal, where are your alternate interior angles? R and W, but which ones? There's 2 angles at R and 2 angles at W. Is it MRW or MWR? MWR. This angle MWR, is congruent to what angle? KRW. By alternate interior angles, okay? If they tell you in the given that lines are parallel, look for alternate interiors. That's what's typically going to show up, okay? So that parallel lines should lead you to types of angles, okay? Okay, so now look at your picture. I just said that, well, look at all your markings. We marked these, and we marked this. Why are those 2 triangles congruent? AAS. Why not ASA? Because it's It's not the included side, right? ASA would be if we knew these two sides were congruent, but we don't. We know they're parallel. We don't know they're congruent. Well, now we do, because we proved the triangle is congruent. But you got to make sure AAS is not the same as ASA. Okay? All right, last thing. Is triangle BIF congruent to triangle UTO?
No.
Why not? They're not corresponding sides. Now, does that mean they're not congruent? Not necessarily. They could be congruent. We just can't prove they are congruent. So you would say there's not enough information because they are different sides, not corresponding sides. Right? This is angle, angle, side with angle, angle, side, but it's not the same sides. Next to the single arc is this side, next to the double arc is that side. Okay, so it's got to be that the congruent sides are the corresponding sides that are congruent. Questions on that? All right, look at 4-4. CPCTC, say that real fast. CPCTC, that's a fun one. We'll get there.